Hello, this is a video for SOEN6441, Advanced Programming Practices. This is for week 11. This lecture is going to be about exception handling. Okay. So exception handling, why I did choose to have this topic, which some might believe it's not a how can I say, an advanced topic. The reality is that a lot of people are misusing or do not really understand what is exception handling. Many people will deal with exceptions, but will not use exceptions. Um, for example, typical thing that we see when people don't know how to use exception handling is that if their program crashes using when throwing an exception, they will actually go in their main function and then put all their code in a try block and have a catch all, and which will then print a trace of the stack, um, the execution stack, thus preventing the main function from throwing an exception. This is very common and shows that uh, sometimes people don't really understand what it is for and what it should be properly used. How is it that it should properly used? So here I'm gonna go over all the concepts involved, trying to clear the field so that everybody is clear as to what it is and how it should be used. Then I'm gonna finish the lecture by giving a more advanced example or design that shows how it should be used properly. Not that it should always be used the way my example will be organized, but at least it shows different concepts demonstrating how you could use exceptions properly in a design. Now, here we start with an introduction of what is exception handling. Exception handling is where when you write some code, you write the code so that it actually behaves according to what it's supposed to do. Very often, as you know, when you implement code, sometimes things don't turn out the way it was supposed to. And this is how sometimes your program will throw exceptions. You may have designed and written your code according to certain situations. There might have something may happen during the execution that will make the code go in a certain direction that you did not expect. Eventually, maybe going in a certain direction where it cannot actually execute the code that you have. Thus, will throw an exception. Okay. So the root of all of this is that when you write code, your program is supposed to run according to what was specified that the code should do. Most specifically, also, what is the context under which this code should execute. Most typical when you have exceptions, many, among other things that are typical when you are encountering exception, for example, you might have asked the user to enter their age on the computer, which of course should be a number, and then the user enters their name instead of their age. So then your scanner, your keyboard scanner will fail because you're trying to essentially read an int, and then the user enters characters, which is invalid, which then your scanner will throw an exception. In this case, you had designed your program so as to allow somebody to enter a value which you thought should be an integer, but really the user entered their name, which is a string, which made the program fail because the user tried to do something which you did not expect. Of course, you could design your code so that it would be more robust so that the program would not fail. One of the things you may have to do is to deal with the possibility that the user enters values which are not according to specifications. So there are different, so basically what I'm saying here is that there may be, as you execute the code that you've written, there might be some unforeseen situations that arise when the code gets executed. So these unforeseen situations, they may come either externally from the environment of the program, such as, for example, the user entering a value from the keyboard, entering a wrong kind of value, making the scanner fail. Or you may read from a file, the file's not there. So you may then again have your file reader to throw an exception. Or your piece of software might try to communicate with another piece of software. Maybe there's a networking problem, so they throw an exception. So these are all external factors that may make your software throw an exception or encounter an error kind of state. It may also happen internally from its own execution. So you may have designed the code thinking that you understood all possible things that may happen. There might be some of those things that you did not expect. For example, it might be a division in your code somewhere. You did not expect that the denominator of this division would be 0. Then you apply the division and then it fails on an error. It's not necessarily through external um, interactions that the software will fail or throw an exception. Thing is that when you design a program, very often a program needs to be robust. So robustness is software quality, which basically means that software should be able to handle all kinds of circumstances. That whatever is the circumstance, foreseen, unforeseen, it should not stop executing because something wrong happened. So robust software will continue executing no matter what happens. Okay. That's not necessarily very easy to achieve. One of the things that is absolutely necessary to have in order to solve this kind of problem is to have exception handling. Well, it's not absolutely necessary. There are other solutions, but exception handling is a very orderly way of actually dealing with exceptional situations. Now, this is not something entirely new. There was, before exception handling became commonplace in many programming languages, there were what was called error handling. So essentially, error handling is, what is exception handling? If you make it very simple, exception handling is your code executes, and at some point in the code, some unforeseen situation happens. And then what needs to happen is that there needs to be communication between this place where the code actually failed, that is going to communicate some kind of error code to another place in your software that's going to try to fix the situation so that it can continue executing even though there was an error that was encountered. Okay. So that involves both this communication mechanism to relay to another piece of code what is the code of, what is the nature of the error that happened, and then depending on what is the nature of this error, that you have another piece of code that's going to try to deal with this error and hopefully be able to recover from this error having happened and continue executing. Okay. So partly communication, exception handling is a communication problem. You need to locate the error and then somehow bring this error to another piece of code that is going to try to deal with the error. So that before we had exceptions, there was what was called error codes or error handling that was in existence, because you can imagine, in order to solve this problem, you just create a variable that is going to contain the error code, and then you make it so that this variable is readable by another piece of code in your implementation. And as soon as this error happens, this other piece of code starts executing, reads the error in question, the error code in question, and tries to deal with the situation. Okay. Or you may have call a function. Then as this function is executing, then it may return a code, including possibly an error code if it actually failed to execute. Then the calling function can actually receive this error code and be able to deal with the erroneous situation. So there's the catching of the error, the fact that you are detecting that an erroneous situation has happened, and then there's the handling of the error, which there needs to be some kind of communication between the place where the code, the faulty code was detected, and the place where another piece of code is going to try to fix the situation or handle the error. That's one of the things that is not so easy to figure out when you have an error that is thrown in a program. Sometimes it is being bounced around in your code, and it becomes very hard to figure out certain errors happening somewhere. It's not always very clear where exactly this error actually happened, as I will explain later. So what is error handling, which is kind of the ancestor of exception handling? So here, this is a typical piece of code here, C piece of code in the C language. So here you have a function named readFile, and then it returns an error code, which is probably an integer kind of thing. And then you see that depending on what's happening, then, well, the default error code is there's no error, but you see that depending on what's happening, either the file is open or not, the file length is maybe too much, maybe you run out of memory, try to read the file, it fails, whatever it is, there's many different error codes that may happen. Okay. Then this file, this function would actually, depending on what's happening, then would either read the file successfully, returning 0, meaning success, or it would return another value, which means error, and then the function that called this function would receive the error code and then be able to hopefully deal with the situation. One of the things you should see here is that all this code here that I have, well, the green code is what, the normal code. The non-green code is actually all code that is there only to trap these different cases and then set the error code accordingly to what is the erroneous things that may happen as this code is executing. You see that there's a lot of lines of code here that are there just to deal with the possibility of errors. Then, of course, in the function that reads, that calls this function, there would need to be other code that would be executed if the return value of this function is not 0, meaning that's an error. So depending on if it's -1, might do something, -2 would do something else, -3, -4, -5 would all do different things. So that's actually adding a lot of code in your code base only to deal with errors. And that's what is not so good about error handling, which is not exception handling. You have to understand that there's no exception handling in this code here. All it does is add code that deals with possible erroneous situations. The exception handling, what it tries to do is to somehow minimize or localize the error handling code in special places that only deal with error cases, so that your normal code is not cluttered too much with the potential, the code that is there to deal with errors. Okay. So here's what it would look like, same code as I have here, if I would have actually exception handling. So what I do is I read the file and I put my normal code, my normal execution code, I put it in a try block. Then any of these here may actually throw exceptions. Each of the exceptions would be each of these different cases, 1, 2, 3, 4, 5. Okay? So that if all of this goes well, then only this code is executed. Okay. So you see that in this code here, I don't have any if and so on, and imbricated ifs and so on, and setting the error codes. I don't have any of that in this code here. That means this code in my try block here, which is the code, the normal code that is executed when everything goes well, is not cluttered with exception handling code. Okay. So that's one of the advantages of having exception handling using a try-catch syntax and mechanism. So this is my normal code. If any of these things ever go wrong, then they may throw all of these different kinds of exceptions, which are my 5 different cases I had in the previous example. And then depending on what is it that went wrong, then you can have a piece of code in each of these catch blocks here that is going to try to fix the situation or enable you to continue executing even though this error has happened. It may also be that this function will not try to catch some of these errors, in which case it will itself throw an exception to the calling function, which is going to then force the calling function to possibly catch this exception having been thrown, as we will see later. So what's important to see here is that my normal execution code here is uncluttered with all of these if then else here that are there to trap all the erroneous situations. And then the branching is made automatically by the try-catch mechanism that I will explain later. Now, some people might think this is new. No, it's not. The notion of error handling or exception handling started to exist in actually some of the first programming languages. So that it was actually present in the Lisp programming language, or an ancestor of what we have now was present in Lisp that was in the early 1960s. And then it was taken over in part by the language PL1, which was kind of a revolutionary programming language that did not see a lot of use, was not very popular, but was actually implementing a lot of very interesting concepts that we have in programming languages nowadays. So exception handling, as we know now, was mainly started to be implemented in PL1. So what is an exception? So an exception is essentially a data structure. So when you throw an exception, you are throwing an object. Now, this object is essentially somehow a code, just like the error codes I've shown you, except that it is an object. And then what is its code? Normally, its code is actually its type. So you throw a certain exception of a certain type that tells you what kind of error actually happened. Now, most exceptions that's when you throw exceptions, that's how that's the only content of the object, its type. It also, they contain a string that allows possibly the programmer to write a string and put it into this exception to explain what actually happened as the exception was thrown. Okay. Now, that being said, exceptions are classes. So you can create your own classes of exception, and the exceptions that you create can have data members, they can have member functions, they can have constructors that you define. That's what I'm going to show later on, and a final example. So an exception is an object that you create when the exception is thrown, and then is communicated somehow, and then caught by a catch block somewhere in your code, as I will explain later. The exceptions are processed by an exception handling mechanism. So you have your normal execution mechanism of your program, then you have the exception handling mechanism that may take over your program if only if an exception is thrown in your program. That's one of the myths or misunderstanding that people have, thinking that exception handling is just normal execution. It's not normal execution. As soon as an exception is thrown in your program, the program stops, then the exception, the only thing that's happening as exception handling is taken over is we have to resolve this exception. As soon as it's resolved, then the normal execution starts again. As soon as you have an exception, the program is stopped. Okay, so you need to have an exception handling mechanism in order to deal with these exceptions. And this exception handling mechanism never executes unless you have an exception that has been thrown. And when the exception handling mechanism starts, it stops your normal execution, takes over the execution of your program, stops the execution, handles the exception. If the exception is properly handled, and gives to turn back to the normal execution. If the exception cannot be handled by the exception handling mechanism, then the program will stop. And that's where you will have your program stopping and throwing an exception. As I'm sure you know that happened to you in the past. So what is the syntax and how does this work? So in Java, you have what is called the try, throw, catch, a keyword trio. So you have a try block, and then you have a throw statement, and then you have a catch block. So you might think, well, C++ took this from Java. No, it's the inverse. Java actually took that syntax from C++. There's a lot of syntax of Java that is taken directly from C++ syntax. So what is it? The try block. A try block contains a part of code, the part of code that is the normal execution of the code, that does not have, that may throw exceptions, but that is normal execution, that is not dealing with the exceptions. It's called a try block because it tries to execute this piece of code that is in the try block. So essentially, a try block is a block of code. What is a block of code? It's several lines of code, or lines of code that are inside of squiggly brackets. Okay. But that is preceded by the keyword try. So, so when you have a block of code that is preceded with try, then this code here starts executing. And then if an exception is thrown here, then it would actually allow the exception handling to start, and then trying to find a catch block, which I will explain right away after, that would be declared right after the try block in question. Why do you put things in a try block? Because you want to have a catch block that's going to catch an exception that would be thrown in the try block. If you would have some code here that would have the possibility of throwing an exception, and you don't put this code in a try block, the effect would be that when you execute this code here, if it throws an exception, if it's not in a try block, then the function would actually stop and throw an exception to the function that called this function, because the exception was thrown that was not in a try block. That's another myth that people, misunderstanding that people have, is that you cannot throw an exception if it's not in a try block. You can, it just happens that the function would throw the exception to the calling function automatically. You put your code in a try block when you want to have a catch block that's going to catch this exception locally, hopefully without the function throwing the exception to the calling function. So what is then throw? Throw is actually where it's a keyword that is used to actually throw an exception where it says it. So you have throw and then an exception that is being created here. So you have throw new exception. So essentially that is calling the constructor of this class here by using the new keyword. And then this exception is created, which is then thrown by the throw keyword. As soon as you execute throw, as the virtual machine executes throw, then the program stops and then the exception handling mechanism takes over, and all it wants to do is to resolve this exception, essentially to find a catch block somewhere that it will branch to, execute the code in the catch block, then give the hand back to the normal execution. So this is where actually when you execute throw, this is really where exception handling mechanism is started. Now, a throw, as I said earlier, a throw can be anywhere in your code. If a throw is happening inside of a try block, then you can deal with this exception locally inside of this function. But in most of the cases, when you have an exception that is thrown on you, is very often you're calling a certain library, certain function in a library, and then this function, if you would look in the code, there's a throw that is not in a catch. Then this function that you're using from this library is throwing an exception inside of your code. Then it becomes your duty to actually catch this exception. So then typically you would actually put this function call in a try block and then provide your own catch block. Okay. If not, if you don't, then your function will, your own function that called this library function would then stop and then throw an exception to its calling function. And it would do that until, yes, it comes to the main function. And if the main function does not have a try and catch, then the main function would stop and your program would halt, throwing the exception. So that's actually why frequently when you see code written by people that don't really understand how to deal with exceptions, they would have their main function that is entirely contained in a gigantic try block. And then you have the code of their main function inside of a whole try block. And then at the end, you have catch exception, which is only doing printing of the exception handling stack. Okay. Basically print out the stack trace. Just kind of indicating that person does not really know what's happening or how to deal with that, or what's the mechanism involved and how can you deal with that more constructively. Okay. So essentially what you want to do when you have a throw, you want to have a catch somewhere. If your program has a throw and nowhere there's a catch in your code, as soon as this throw is going to be executed, eventually it's going to make the program crash. If you have a throw somewhere, there must be a catch or else the program will fail. So somehow a throw statement is similar to a method call in the sense that it receives a parameter. So the parameter to throw is the object itself, and then this object is of a certain class, a certain type. Okay. Then what it does, the exception handling mechanism, is that it tries to find a catch somewhere that catches an object of this type here. If you throw a certain type, you must have somewhere a catch of this exactly the same type or super type. And again, as soon as you execute throw, it's going to stop the execution, normal execution of your program. It's going to start the exception handling mechanism, whose goal is to find a catch. You also have Okay, yeah. So eventually what you want is to have a catch block like this, and then a catch block essentially is somewhere where the execution, the exception handling mechanism will try to branch to in order to resolve a throw. So for example, if you had a throw class name, then it's going to want to find a catch class name. So here you have catch exception. Now exception in Java, you can only throw objects which are, as we will see later, for example, a subclass of the superclass exception. Now, if you catch exception, that would mean you catch anything that is of type exception or any of the subtypes of exception. Now, a catch block has one and only one parameter in Java, which would be of one of the exception types. Then as the exception handling mechanism finds such a catch block, then the exception that was thrown is literally passed as a parameter to this catch block. Similarly to when you actually call a function, you are passing a parameter. Now it's not a function, it's a catch block, but still the exception is passed onto this catch block. Then the catch block can use the exception. It's possible that the exception would contain values, for example, that would be used by the catch block here, as we will see in the example at the end. Okay, so, and then also the type that you have here actually makes it, it determines what kind of exception that a catch block can handle. Of course, then the catch block should be attached to somehow a try block. There's no such thing as a catch block that is not attached to a try block. Suppose you can have a try block that does not have any catch, but you cannot have a catch block that is not connected to a try block. So a catch block is actually often called an exception handler. But why? Because here you have exception that may be thrown. If it gets thrown, for example, if exception type 1 gets thrown here, then exception handling mechanism will take over and then go sequentially over the list of the tries here and then try to find exception type 1. If it finds it, then it's going to branch here and execute this code here. And once the code finished executing, then the exception has been handled and the normal execution resumes. Also, a catch block can execute this type of exception or any of the subtypes of this type. It also executes or tries to find a catch block in this sequence that you have specified here. So that's why if you put catch exception here and then catch a subtype of exception here, this one is never going to be branched upon because the exception handling mechanism looks over sequentially over the catch blocks. Okay? And it will branch upon the first one for which there is a match. So if you put catch exception, it will catch all of them. And if you, even if you have catch something else here, it's never going to reach there. In Java, you have what is known as the finally block. Now, that's the notion of the finally block is some piece of code that is executed independently on if you had an exception that was thrown or if no exception was thrown. Okay. So eventually you could have finally block is not something you need to have. For example, there's no finally block in C++. So essentially, finally, block is a way to factorize codes. For example, if you have always the same thing that's happening in every of your catch blocks, then you would factorize this code and actually put it in the finally block. Okay. And of course, if you execute the try block and there's no exception, then it would actually also execute the finally block. There is also kind of recently, something that was added is the try with resources block. So essentially, the try with resource is a try for which you have between parentheses here some variable that may be instantiated, okay, that is used inside of the try block here. Now, what's going to happen if you do that is that it's going to try to, after the try block is going to be finished executing, then it's going to actually call the close method of this variable br here. So here you're creating a buffer, you're opening the buffer here, and you're using the buffer here. And at the end of the try block, then it would actually call close on this buffer. Same thing is with a file. For example, if you open a file, you have to close the file, or else this resource is going to be hung onto this program. You have to close it. So that's, and then this happened actually independently of whether there was an exception thrown or an exception was not thrown. So that allows you to automatically close resources independently of whether or not the try block successfully executed or not, or if it threw an exception. So this is to sum up here. So there's eventually three things that can happen. So you can have a try block inside of your function, and then there can be catch blocks after this try block. Now, the first case is that you execute the code in the try block, and there's no exception that is being thrown. So you would then execute all the statements in the try block, and then, of course, as you reach the end of the try block, of course, you would then skip all the catch blocks, because the code in the catch blocks is only to be executed if an exception is thrown. Then you would continue execution at the statement that is after the last catch block for this try. So that's basically the case where nothing wrong happened. So you see that the only thing you executed the code in the try block successfully. Second thing that may happen is that you had a try block with some code and you had some catch blocks, but at some point in time in the try block, an exception was thrown as you executed one of the statements somewhere in this try block. Now, what's going to happen if it thus happens, if an exception is thrown by one of the statements, then this try block stops executing. Now, what that means is that there is lines of code below this one, between the place where the exception was thrown and the end of the try block. This piece of code here is never going to be executed if this exception was thrown. Now, that's actually crucially what's important to understand if you want to recover from this error, because these lines of code that you're not going to execute, they were certainly doing something important, possibly doing something important. Now, how are you going to be able to continue executing this program considering that these lines of code did not execute? Now, this question should be answered in your catch blocks. The catch blocks are going to be there to try to make it so that, yes, you can continue executing this code without these lines of code having executed. Okay, so in order to do things intelligently after, if you want to resume execution after the exception has been thrown, you have to deal with the fact that some code was not executed, and that would be done in your catch block. Then, well, these lines of codes are skipped, and then the exception handling mechanism takes over, and then as this code was in a try block, it's going to try to see after this try block if there's some catch blocks, or one catch block that corresponds to the type of exception that was thrown inside of the try block. If it finds one, then it branches upon this catch block and then executes the lines that are the statements that are inside of this catch block. Once it executes the last line of code in the catch block, then it gives to the It gives back the control of execution to the normal execution mechanism, which would then execute the next statement after the last catch block. So that is basically this case, is that you have a try block, exception was thrown, which was able to be caught locally by one of the catch blocks defined in this function. Okay. So that's basically the exception was caught locally. Third case is that you cannot catch this exception locally. Now there's two possible cases here. Either in your code, you don't have a try block, but an exception is thrown outside of a try block. If that happens, there's no try block, so there's no catch block. So this function cannot handle this exception locally. Then what happens in this case, as soon as the exception is thrown, exception handling takes over. It was not in the try block, there's no catch block. So right away it says this function is halting. So all the lines of code that they're after this line of code that threw an exception are never going to be executed. And this function is going to somehow stop, and then it is going to throw an exception in its calling function. Then the same thing is going to be repeated. Is this function call in a try block? If it is, then it's going to do what I've described before. It's going to try to find the corresponding catch block. If it finds one, it's going to execute it. If it executes it successfully, then normal execution resumes. But if in this calling function, there's no try block, or the calling to this function is in a try block, but there's no corresponding catch block that can catch this exception type, then this function will also stop and then throw the exception to its calling function. And then this might repeat until it actually, all your functions on the stack are halting until you reach the main function, in which case, if the main function does not have a try block or does not have the appropriate catch block, then the main function is going to halt, program is going to halt, throwing exception. Okay. So these are the three cases that may happen. Either try block, execute your code in a try block, no exception, so that's normal execution. If there is an exception in your try block, then it's going to try to branch in a catch block. If it does, execute the catch block, continue execution, even though the code in your try block that is after the place where the exception was thrown is never going to be executed. In this case here is the combination of cases where the code that threw an exception could not be handled locally by a catch block inside the function where this exception was thrown. Okay. Now, there's another thing that happens when the exceptions are resolved, which is called stack unwinding, which is not many people really understand or are even aware that this is happening. Now, remember when I said if your function throws an exception, if the code inside of your function throws an exception, then if this exception cannot be handled locally by this function, then this function will halt and then throw an exception to its calling function. Now you might think, well, that means that the function is returning, stopping and returning its value to the calling function. No, it's not. It's not returning. It's just, it stops right there. Problem with stopping the execution of a function is that this function was holding resources. It was holding some variables which were held on a stack frame in the execution of this program. Now, this stack frame somehow needs, if the function halts, the memory that was held by the things that were on the stack frame for this function, they have to be dealt with, okay? Because keep in mind that as this is happening, It's not the normal execution anymore that's happening. Normal execution deals with a function that returns its value, and then its stack frame is somehow freed. Then the execution of the preceding function continues after it returns its value to the calling function. That's how normal execution happens. In our case, function executed, the function that is currently executing was using the top stack frame. Then it executed some of its code and then threw an exception. Then if it cannot handle the exception, then it halts and then throws the exception to the calling function. So the exception handling mechanism must do something with these things that were held in the stack frame of this function, which is called stack unwinding. It's called stack unwinding because this thing that I described, that this function on top of the stack, the function called stack throws an exception. Then it throws the exception to the calling function. If this one can neither catch the exception, then it's going to throw to the calling function and so on. So the stack is going to be somehow popped, but it's not going to be managed normally in using the normal memory management of stack operation, a normal stack operation memory management. So stack unwinding is there to actually deal somehow with this fact that the functions stop executing without being managed by the normal execution mechanism. So as soon as the control goes to the catch handler, process of stack unwinding is used to release all the local variables that were used in this function between the execution site where the exception was thrown and the execution site where the exception is caught, which can be in another function, because an exception can be thrown in a certain function. This exception is thrown here, and this function here was called by another function. Now, as the exception was thrown here, it's possible that certain variables were already declared before the site where this function was declared, where this exception was thrown. There might be other variables that were declared below this site, which are not allocated yet, and that's the problem. So the stack unwinding only deals with things that have been allocated as of now. It cannot deal with things that would be allocated after the point where the exception was thrown. Then as function gets throws the exception to the calling function, then they must deal the exception, the stack unwinding deals with the memory that was allocated to things that were allocated before the point where the exception was thrown. Then if it throws to the calling function, same thing happens here. The point where this function was called, there was some memory that was allocated here. There were to be some other memory that was allocated here, but that was not executed yet, so it's not allocated yet. So if this function throws the exception to the calling function, then these variables must be freed. So that's what the stack unwinding mechanism deals with. So yes, functions are stopped, but nevertheless, their stack frame must be somehow freed, or what was used effectively must be freed. So here I wrote a little program here to explain what is happening in the stack unwinding, or to actually trace what's actually happening. So what's happening here is that I have my main function here, and then this main function, as we see here, is calling this f function. And this f function is calling this g function. As we may see, there's a try block inside of my main function, but there's no try block anywhere in the f or the g function. Then there are some variables which are created here before the try, and then here before the point where here, as you may see, I throw an exception here. When do I throw an exception? I throw an exception depending on a value that was entered by the user. Okay. So if the user enters M as the program starts, then this would throw an exception. If the user enters F, then this here would throw an exception. If the user enters G, then this here would throw an exception. If the user enters X or anything else, then no exception would be thrown. Okay. Now, what this actually is showing is what are the variables that were created before the exception was thrown. So clearly here you see that always this variable will be created. Always this variable will be created. But depending on if M was entered by the user, which would make this throw an exception, if user entered M, this would not be created. Rather, this would be created because this is in the catch block that will be branched upon as you are throwing this exception. So if you throw an exception here, this is not created, but rather this is created. Then after you catch the exception, normal execution would resume, and then you would create 9. Now, let's say the user enters F. Okay. So if user enters F, that does not throw an exception. It calls F here. Then F is actually creating MC2, and then we'll throw here. Now, here you see that this throw is not inside of a try. So it will right away throw an exception, or it will right away makes this function throw an exception to its caller because it's not in a try block. So right away here, this will throw an exception, and then which will make this function call here throw an exception, which will make it, the exception would be thrown here, which will then be caught by this catch block here. So you see here, exception was thrown in this function stopped executing, and then this function called through the exception, which was then caught by this here. So you see that the catch block here you have throw in this piece of code here, which is caught by this other function here. That's what is confusing when you're trying to trace where exception is being caught. It's hard to figure out where exactly, where in the function called stack this an exception will be caught. Now, if the user enters G, then as you come here, then oops. If the user enters G, then this would not throw. So you would have 1, 6, and then call F here. F is executed. Then you create 2 and call G because this does not fail because the user entered G. You come here and then you create 4 and then you throw here. Throw again here is not in a try block, so there's no catch block. So this function stops and then throws the exception here. Then as this throws an exception and it's not in a try block, this function itself halts and then throws the exception here. Then, which is in a try block, which is then caught by this here. So that creates 8 and then creates 9. Okay. So these are all the 4 cases that I'm showing here. Okay. So I invite you to look carefully at this. So it's easy when I say it myself to think you understand, but I invite you to actually trace it yourself to see what's actually happening. Now, another thing that is troublesome when you deal with exceptions, especially if you have exceptions that are thrown in constructors. Why is it problematic? Because constructor is there to create an object. if an exception is thrown inside of a constructor, the fact is that there is going to be some part of the constructor that would have executed, and some part will throw an exception, and then the part that is after that will never be executed. And if the exception is not caught inside of the constructor will halt. Thus, it would have executed some part of code through an exception, and then some other part of code is not executed, and the object that it was created does not exist because the constructor does not resolve. The object exists only after the constructor fully executes. If the constructor throws an exception, the object was started being created, so it's holding some resources possibly, but the object was eventually not created. The problem with that is that, remember, your garbage collector will eventually collect or free the memory for the objects that you have created. That's the key word. Here you have called a constructor, but as you were executing the constructor, it failed. So the object was not created. So it cannot be freed because it does not exist. Okay. So that's actually creating a memory leak. Even though you might think that Java is kind of immune to memory leaks because of the garbage collector, well, if you have an exception thrown in your constructor, you may have your Java program have a memory leak. So here I designed another simple program that is doing roughly the same thing as was done before, except that here it's actually throwing exceptions in constructors. So what you see here is that the program is creating an object of type A inside of a try. And then somewhere in the constructor, the constructors, you will have a throw statement. So if the user enters A, then the constructor of A will fail. If the user enters B, then the constructor of B will fail. The fact of the matter is that this A class actually inherits from B and then has a member C and D. Okay. So if you want to create an object of type A, first thing that happens is that it will create the parts C and D of this object A. Then it's going to call the, it's going to first call the constructor of the superclass of A. Then it's going to create the B part of this object A, because if A extends B, that means A has a part that is a B part. So first thing is going to happen, the runtime system is going to create this B part. Now, B does not inherit from anything, so B does not have an inherited part. It does not have data members, so the only thing that the only part of a B is the B itself. Now, after this is done, then the part C and D of the object A, which are its members, would be created. So then the constructor of C would be called and the constructor of D would be called. So essentially, when you create an object of type A, using new A here, then first thing that happens, the constructor of B is called, then constructor of C is called, then the constructor of D is called, then the constructor of A is called. So you must create all the parts of an object before you actually call the constructor of the entire object. Now, of course, if B throws an exception, then you would have this. If the user enters B, then the B constructor would throw an exception. So as you're trying to create the A, then it would fail because the constructor of B would fail. Now, that's not that much of a problem, but imagine if the user enters D. If the user enters D, as we see here, so the constructor of the B part is called successfully, and then the constructor of the C part is called successfully. And then as the constructor of the D part executes, it's throwing an exception. And then, as you see, the constructor of A is never called. Okay. So this object A does not exist, so it cannot be freed. However, the B part and the C part of this object have been created. So they're just going to be floating around and they cannot be freed because their parent object does not exist. Okay. So all this to say that having exceptions be thrown in constructors, especially if you have inheritance or data members that are of other class types, can create memory leaks. Now, another thing that is to deal with exceptions in Java is what is called a handle or declare rule. So handle or declare rule has to do with, when you have a function, sometimes you have a throws clause here at the end of your function header. Now, what does that mean is that actually means that this function here can actually throw an exception of this type. Remember when I explained the mechanism by which a function, if it cannot catch an exception locally, then it will throw a function. Fact of the matter, if it can throw a function, it must actually be specified here at the level of the function header. Okay. So in fact, a function must either, if its code inside of the function body, if its code can throw an exception, it must either catch this exception internally using a catch block and a try block, or if it doesn't, then it must specify what is that it can actually throw this exception. Then it makes it so that if a function is calling this function, then it makes it so that the compiler can detect that this function here can throw this type here, then can actually determine whether this calling function is either catching this type of exception, or if not, then it would need to actually itself declare that it can throw this exception. Yeah. So that's what is called the handle or declare rule. This is kind of a controversial rule that was implemented in Java because it has a tendency, if you don't have catch blocks anywhere in your code, that somehow forces you to have many of your functions that will have throw clauses. So it creates a proliferation of throws clauses in your code. Okay. Now, this happens, this applies only to what is called checked exceptions. What are checked exceptions? Well, you have your exception class here and many different system level exception classes or exceptions that you may define yourself. An exception is a subclass of the class throwable. There is also some other subclasses like error, which are not subject to the handle or declare rule. So example, runtime exceptions, for example, a null pointer exception is not an exception per se, it's a runtime exception. And these runtime exceptions don't need to be specified in a throws clause because they're not subject to the throws clause because they are unchecked exceptions. Okay. Now, what if you want to, and that's where I start heading into my final example that's trying to wrap everything together, okay, and then showing you kind of a more advanced design that is using its own exceptions. So you declare your own exceptions. Plus, I have included in the design the fact that these exceptions are actually holding data that is helping the program to actually achieve some of its goals. Okay. In many cases, vast majority of cases, exceptions do not hold data. They're not objects that hold data, except possibly the string that describes what happened when the exception was thrown. Here I have my own classes. my own exception classes hierarchy, and I actually define some data members inside of these exceptions. So my exceptions that I create are subclasses of the exception. So they are actually checked exceptions, right? So here I have my class hardware exception, that is a subclass of exception. And then I have actuator exception that extends hardware exception, that is itself a subclass of exception. And then I have stuck valve exception that extends actuator exception, so on and so forth. So I have a hierarchy, I define myself a hierarchy of exceptions. Now you may see here that, yes, they are all subclasses of exception. In Java, you can throw only objects that are essentially subclass of throwable, but in most cases, a subclass of exception. So that's what allows me to throw these objects here because they are a subclass of exception. Now, one of the things I'm going to be doing here is that my exceptions are going to be thrown by a piece of hardware, or that's a simulation that I'm doing that there's a piece of hardware in my program, and then this piece of hardware can throw an exception. Now, what I want to do is to record the time at which this exception was thrown, so that the exception itself somehow contains information that is useful to know in order to deal with the exceptions or to report the exceptions. So you see that my exception actually contains a string that is going to contain the time at which the exception was thrown. Okay. Then I also have my subclass of hardware exception, actuator exception, because in my example, there's going to be a valve and there's going to be a sensor. A valve is an actuator. So you basically tell it to open or close. It does an action. So it's an actuator. In my design, there's a valve. It's possible that this valve will be stuck, at which point it would throw an exception saying that it was stuck. So here it basically will contain the state in which the actuator was when it was reported to be stuck. So the actuator is either open, the valve is either open or closed. So when the exception is going to be thrown, it's going to record in the exception whether it was closed or open. So you see that my exceptions, they actually contain valuable information that I'm going to be using in the mechanics of the implementation of my code in order to achieve useful things during execution. Okay. So I invite you, I'm not going to explain everything here, just going to go over the overall design to explain how does it use exceptions according to what I explained in the lecture. If you want to have more details, please go to the lab and listen to the video that the lab instructors did for this week. So yes, there is other subclasses of my exceptions. Basically here I have my whole inheritance hierarchy of different kinds of exceptions. So I have, for example, there is also a sensor, a pressure sensor in my design. So the pressure sensor can throw exceptions if the pressure is above the normal reading that it's supposed to deal with, or if the pressure is negative, it's going to throw an exception. So you see, I have overload pressure exception, negative pressure exception. But essentially here I'm creating a sub-kind of exception for all the different ways that things can go wrong. Then eventually, of course, I'm going to have catch blocks that are going to catch some of these depending on what kind of exception they are. And I'm going to use this in the mechanics of my implementation to make decisions as to what to do when a certain exception has been thrown. Now, here's the overall design here. So the idea is that this is essentially a boiler, an industrial boiler. What is a boiler? Essentially a tank that has some liquid, and that there is some heat that is applied on this liquid, and then it starts boiling. And as it boils, as it is a closed container, and the pressure inside the container starts rising because of the boiling. Then I have a pressure sensor that is reading the pressure inside of the boiler. Then, as a security measure, I actually have a valve that I can open if the pressure gets to above a certain threshold, so that the boiler does not explode by going by having too much pressure. So extremely simple. You know, don't expect this is how an industrial boiler is operating. It's a very simplified version of it. So I have a tank, and then I have my pressure sensor, and then my valve. And then my software will read the pressure, and if the pressure is above a certain threshold, it's going to try to open the valve. Then, if the valve is stuck, then it's going to declare an emergency. And then, as another additional important requirement here is that what I want, of course, then have my main program here, which is my boiler class, which has a start method, a shutdown method. And then basically what it does, it just reads the pressure, read the pressure. If it goes above a certain level, then it basically wants to open the valve. If the valve is stuck, then declares an emergency. Shuts down the boiler. Now, to make it more interesting from the perspective of our topic now, what I want is that this code here will never know that these components here, the valve and the sensor, can actually throw exceptions. So in their normal operations, these two things here can throw exceptions. The valve can malfunction and say, there's a million kPa of pressure, which is wrong, so it will then throw an exception. And then when you open the valve, it's possible it's going to be stuck, then it will throw an exception. So now what I want as a special requirement is that the boiler should never receive any exception. Okay. So yes, the boiler is going to use these here, but as a requirement, I'm saying the boiler should never deal with any exception, should never have a piece of code, a line of code inside the boiler that is catching exceptions. Now, what I'm going to do is I'm going to create these intermediate classes that are essentially going to be some kind of adapter that allows the boiler to actually use the valve here, but that if this one throws an exception, that it's going to be caught by this adapter here. And if the boiler uses the pressure sensor and it throws an exception, it's going to be caught by this here. For example, the boiler, as it operates, it's going to call get pressure of the adapter. And then get pressure of the adapter is going to call get pressure of the sensor. If get pressure of the sensor throws an exception, then it's going to be caught by this function here. Okay. Same thing for the valve. Another thing that my software is supposed to do is to report. Okay, so that when I read the pressure, then it should actually report in a log file what were the pressure readings that were actually read from the pressure sensor. That's why I have my pressure report file. So eventually also there is, as I have writing into a file, opening a file, writing into a file, it's possible that opening the file or writing into the file is going to fail because, for example, it's what if the file ceases to exist as the program executes? So then I'm going to also have this intermediate between the file and the boiler. Okay. So this is my code for the boiler. And you see that it basically opens the files and so on. And then it creates the pressure sensor and a pressure and release valve, and then connects them into these connectors or adapters. So when it uses PS here, the pressure sensor, it's really using the pressure sensor connector, which then uses the pressure sensor. So the pressure sensor can throw exceptions, which are going to be caught by the pressure sensor connector. Now you see that as you execute the boiler, what it does is basically it calls the get pressure. Okay. It calls get pressure of the pressure sensor, and then the pressure sensor connector get pressure. What it does, well, first of all, the pressure sensor connector is connected to the pressure sensor, which is this one here. Then, as you see, the pressure sensor, well, here it's just simulating the pressure sensor, and depending on the random factor, it may throw an exception. It may throw either negative pressure exception or overload pressure exception. You see that if it throws the exception, there's no catch here. So it's going to throw the exception to the calling function, which is this one here, get pressure, that is calling get pressure of PS, which is the pressure sensor. So as it calls get pressure here, if it throws an exception, then this is going to throw an exception, which is going to get caught by this here. Then, as you see, then it's going to write into the file, reporting that there is an emergency situation, that the boiler is now unsafe because the sensor is actually faulty. So you need to shut down the boiler. So you see here that the shutdown of the boiler is actually done by the connector when an exception is thrown by the pressure sensor. You see here, this is how I actually incorporate in the mechanism of my design the notion of exceptions being thrown and being caught by other parts of the code. Okay. And then depending on what is happening, then I actually take actions that make sense somehow in the mechanism that I'm trying to implement. Okay. Okay, so the same thing happens when I have my valve, because of course, if the boiler goes into the unsafe state, then if I'm the unsafe, if I'm in the, I'm not in the safe state, then basically what I want to do is to open the valve to release the pressure. Now, if I try to open the valve and to release the pressure, then basically I'm going to call open. Okay. Now, if I call open, it's going to call open of the pressure release valve from my pressure release valve connector. So when I call open here, again, I simulate that it's possible that it's going to be stuck, and that's what it's going to throw an exception. Then if I try to open the valve and it throws stuck exception, then this is going to throw a stuck exception because there's no try here. So it's going to throw here. This is in a try, so it's going to be caught here. Then as I'm trying to open the valve, if it threw an exception, then I basically put my boiler in a critical state. And then I essentially call for an evacuation of the building. Okay. So this is the example. So let me sum up what are the important things to realize here. That here I'm showing how I can create my own subclasses of exceptions. And I can actually have my exceptions to contain valuable information. For example, if I throw an overload pressure exception, inside of the exception, when I create this exception, I'm actually recording the time and storing the time in which this exception was thrown, which is valuable information to actually report in the emergency file when exactly this exception was thrown. So you see that my exceptions here are not just exception that is thrown and is just a messenger with a type. It also contains valuable information to implement a mechanism that results from this exception to be thrown. Then I had this additional requirement here that I didn't want my boiler to be aware that there were exceptions, despite the fact that the valve and the sensor can throw exceptions, and that of course the writing into the file can also throw exceptions. So I designed those in yellow here, designed them so that they will actually be intermediates that will, yes, call, for example, call the get pressure from the sensor and will catch the exceptions so that the boiler itself will be able to read the pressure and never be aware that an exception has been thrown. So here's some concluding remarks. I'm going to go quickly over these. So there was actually one of the persons that made exception handling more popular is Bjarne Sturstrup, who actually implemented C++. Not that exception handling has not been done in other programming languages, but C++ is one of those languages that made it more popular among the crowd of programmers that we have. So somebody asked Bjarne Sturstrup in an interview questions about exception handling. Example, does exception handling solve all your problems? His answer was no, it's just a mechanism. It's just a tool that is provided to you that enables you to handle these situations in a more orderly manner. Okay, it's just a mechanism that allows you to control how to deal with abnormality of execution in your program. Is this a radically new way of dealing with errors? Well, as I tried to explain in the beginning of this lecture, it's not a new way to deal with things. It's just a more orderly way to deal with things. Okay. And it has its own mechanism that if you use exception handling, you must abide with how the mechanism is actually working. If you don't have the exception handling mechanism, then you can implement error handling, but then a lot of different programmers would have their own way to deal with it. And that creates a lot of variation and potentially a lot of confusion across different programmers that are using different techniques to deal with error handling. So exception handling has its own syntax, has its own mechanism. And if you use it, then it basically forces you to do error handling or exception handling in the same way that is compatible with the mechanism of exception handling. Now, what is some people might be worried that if you use exceptions, then it's going to make your program consume more memory or run slower. Well, the way it is designed, as I have explained, is that it only is, I would say, it takes execution cycles if the exceptions are thrown. If the exceptions are not thrown, then that is, well, roughly speaking, there's no overhead. If you have a program that has try blocks inside of the code, it does not run slower to have actual try blocks in your code. Well, without going to the details, yes, there is things that are added in your executable when you put some try blocks, so as to enable the exception handling mechanism to do some branching to your catch blocks. So the more you have catch blocks in your code, the more these special codes need to be present in your executable, and it's somehow by a very small margin increasing the size of your executable. What is really potentially problematic is if, well, the mechanism that is part, or the part of the mechanism that is most consuming of time consuming and memory consuming is when the exception handling takes over and it's trying to find a catch block. So then there's going to be kind of a search procedure that's going to be fired that is going to look into all the catch blocks somewhere in your code and try to figure out to which one to branch to. Okay. Now this find, of course, when you do a find, any kind of find operation, its cost depends on the number of elements that you over which you have to find the correct element you're looking for. Now, basically what that means is the more you have catch blocks in your piece of code, the more the exception handling mechanism is likely to take more time on average. Okay. Of course, what you don't want, the ultimate thing that you don't want, is that you would have a piece of code that you write, and that there might be a certain loop that this piece of code is executing. Say 99% of the time, it's running in this loop here, and in this loop, you would have an exception that is being thrown, and that in this this piece of code, there is a try block and then a very long list of catch blocks. Or that there's a function that executes this loop that is actually called by a series of functions that themselves have all their catch blocks and so on. Basically, that you have a lot of different catch blocks that are considered every time an exception is being thrown. And that is, of course, compounded if an exception is very frequently being thrown. So what you don't want, if you're concerned with the overhead of exception handling, the situation you don't want is to very frequently throw exceptions in a piece of code where there's a lot of catch blocks that are potentially involved. But the real difficulty, as my last example was trying to exemplify, is how do you design your code? How do you make it so that your code can really recover from exceptions? As I was explaining in the beginning, when you execute a try block, and then in the middle of your try block, there is an exception being thrown, then there you have some number of lines of code after this that will not be executed. Now, how do you recover? How can you possibly continue execute a piece of software if there are some lines of code that were not executed? That is also one of the difficulties of programming with exceptions. How can you recover from the fact that there are some lines of codes that were not executed as a result of throwing an exception? So that's the big question. That's, can't answer this question by a simple answer. It all depends on every possible situation that it can happen. That's the real difficulty with programming with exceptions. So that's it for this lecture. Thank you very much.